now. Okay, and to begin with, this is some example of the particle size of the toners, and this is particle average particle size is 9.0 micron, and this is our actual products and very narrow particle size example. So below 5 microns, 1.2%, above 50 microns, 0.3%. It's very narrow particle size. And the other example of the metal powders, this is an example for solder type 5. Solder is, as you know, that is used for the electrical systems, many electrical equipment, and so solder powder is used in dry in a manufacturing process. And solder particle size distribution table example. There are so many type of particle size of the solder, and type 2 to type 5 is common. So most of the particle is 95% of more or between 75 to 45 micron is a type 2. So type 5 is 15 to 25 micron is most of the powders are in this range. And recently, particle is getting finer now, type 6, 7, 8, 9. So this is an example of the particle size. And key for air classifier in producing toners or metal powders. In the fine plastic and metal powder industry, classifiers are very important for the powder process as well as grinding mills in general. Required fine powder for 3D printing is similar in concept to toners. Powder flowability, particle size is becoming finer for quality reason. Surface smoothness from 50 to 20 microns or finer. So for the classifiers, coarse particles should be sharply discarded from particles to determine top size of the products and collect the powders. Only with the maximum yield. For pulverizers, powder should be effectively ground to fine powder in a short time by using less energy. Also, fine powder as a pulverizing should be quickly discharged. So classification and grinding are both principal technology in sharply adjusting particle size and economically grinding particles. This is generally air classifier technology is generally used for fine powder field in especially less than 10 microns of fineness range. But recently, sieve is used now for this type of very fine powders, 10 to 20 micron range. But first of all, let's explain the classification, how classifier is used. This flow sheet shows a toner grinding and the classifying process. So fine grinding process and the fine classifying process. This is our toner raw material is fed to the mechanical mill, pulverizers, and pulverized powders is going to classifier, and the coarse powder is recycled to the grinding machine. But the fine powder is going to next stage, and another classifier is used for removing cores. So product size after removing cores and after removing cores and removing fines, then this is a removing fine side, and the product narrow particle size product is collected. This is toner process. And depending on the grinding systems, generated particles below a 5 micron range is different. So fine particles less than 5 micron, volume percentage, this is our fine powder rate, volume rate after pulverizing. So by using mechanical mill, less fine powder is generated than jet mill. That's the this is a toner case, and the next one is a magnetic. So product yield is also different because of the fine powder. Mechanical mill and classifier process can produce a very high yield, higher yield than the jet mill. Almost 90% can be produced with a mechanical mill because of the less fine powder production. And another, but this is specific energy consumption is also different. So mechanical mill is generally shows less energy than the jet mill. And regarding the toners, the toner shape, there's several factors, and in case of using surface shape factors, this is our definitions. Perimeters by perimeters divided by 4 pi and the square. This is the surface shape factors. So smooth and rounded surface shape is 1. This is a spherical case shape. If we use surface shape factors, this is our actual photograph. Surface SSF shows 1.41 after the jet mill used. The other jet mill is also this type of very not round. It's kind of because of the shape. But mechanical mill, it's a little bit round shape. The round, because of the round shape, this factor is close to 1. That means close to round shape. So there are several classifiers. A classifier, there are so many classifiers. Rotor type, this is our AccuCut rotation type, and microcut. That's also rotor is inside, and micron separators. There's a top rotor is on the top, and the elbow-jet does not use any rotor inside. By using Coanda effect, powder can be separated to 3 fractions at the one cut. This is a unique air classifier. And the microspin is used with a jet mill. There's several type of classifiers. And this is one example of the turbo classifier, cross-section view, and rotors, classification rotor and the balance rotor is inside and rotates at a very high speed. And coarse powder is driven out by a centrifugal force, and fine powder is driven in by a drag force. So by changing rotation speed and airflow rate, cut point is adjusted from fine to coarse. That's the concept of the turbo classifier. And so this is a principle of air classification of the rotor type. And another elbow-jet air classifier is different. Elbow-jet, this is elbow-jet, and so powder is fed with a feed air, and powder is classified to fine and middle and coarse one. So 3 fractions: fine, middle, and coarse. This is no rotor is used by using just Coanda effect. And elbow-jet classification, this is also used for the fine powder process. And feed is a particle size distribution of the feed, and the fine, middle, and G means grid. Grid is coarse one. And particle size distribution is beautifully separated to each fraction. And feed capacity can be from low feed rate to large flow feed rate. Of course, depending on the model, small model to large model, the produced particle size distribution is very equal. That means scale up is very successful. So there's also other pulverizers. Many types of pulverizer: fluid energy mill, and agitating mill, ball mill, vertical roller mill, mechanical mill. But today's I just showed the photos. This is the jet mills of the NPK. This is our Nippon Pneumatic exam, and this is our turbo mill by Freund Turbo Matsubo manufacturing. These are mechanical mill, and this mill can be used with a jet mill, elbow jet air classifiers. This is a classifier part, and this is a grinding machine part. This is a closed circuit pulverizing and classification system. In a mechanical mill, this is a mechanical mill cross-section view, and powder is coming in from the bottom and going through between the rotor and the liner, and both sides there's grooves, and the powder is pulverized. So, but this is our same flow scheme system flow. So let's skip. And classification efficiency index. Let me explain classification efficiency index. We call kappa. This is similar to K, but we call it the kappa. dp25 and the dp divided by dp75. So particle size distribution is like this. This one. Like this is a feed, and after the particle classification, fine powder yield and the coarse powder particle size distribution is like this. So if we calculate particle separation efficiency, in powder in the feed, 50% powder goes to fine and 50% powders to coarse side. We call it that this is a 50% cut point microns. So dp50 is, we call it usually cut point. So that means no powder, no coarse powder is going to fine side. Then this is called the dp0. So the other side is the dp100. So but dp25 and the dp75 also can be calculated. So 25% partial separation efficiency, and this copper dp25 divided by dp75, if it is calculated to 1, that's our ideal classification, but it doesn't happen in general. But 0.7 or 0.9 is a good efficiency. So in order to determine the classification is working efficiently or not, we generally use copper. So let's see a copper in toner classifications, and also so feed rate is going down. Kappa is also going down. This is a 12 micron cut point range. The other, okay. So this classification, this is a classifier explanation. And also, so 10 micron, 9 micron range in many production factories, classifier is used. But recently, sieve is also used for the very fine particles production range, such as solder powders. This is our sieves are oblong opening and the square opening sieve examples. And so oblong opening is spelled, but oblong opening is if powder is spherical, solder powder is spherical powder. So this is if it is a square opening, 4 points contact, and but if oblong sieve is used, 2 points contact, and if powder is spherical sieve, oblong sieve can produce can improve sieving performance. So this is also and recently square opening metal mesh recently 20, 60 micron, 30 micron opening wire mesh is available now, and it is used for the metal powder production factories. So in the toner grinding process, mechanical mill produces less fine particles below 5 micron, more rounded shape powder than jet mills. In the toner grinding process, mechanical mill can be used down to 6.5 micron average. Sieve is also effectively used for classifying spherical metal powder down to 13 to 16 micron range cut size. And summary 2, in order to efficiently prepare fine powder, it is important to do a suitable grinding or classification machine for particle size and characteristics. Using grinding and classifying technology, it is possible to produce plastic powder for 3D printing similar to toner in particle shape and size distribution if the target is 10 microns or finer in D50. In the trend of particle size of metal powder, air classifier can be used as a replacing of the sieving technology for the below 44 microns. 3D printing resin plastic characteristics is different from toners and relatively more difficult in powderizing. Development effort of powderizing is required with 3D printing technology. It's not explained in detail, but this is my summary. So thank you for your attention, and if you have any questions, please feel free to let me know.